All right, so now that you've done the peristernal lung axis, we'll move into our 4-chamber views. This is Brock Lesnar, big fan of the sub-xiphoid view, and that's his manager who is impressed at his physique, I guess. So he loves it so much, he got a big brass knuckle sword tattooed where the probe goes. For this view, we're just below the xiphoid, right? Sub-xiphoid probe marker is to the patient's left, and we're angling the beam sort of at the left shoulder a little bit. You're shooting through the liver, so oftentimes it's helpful in this view to have the patient take a breath in and hold it, because that flattens the diaphragm and brings the heart closer to the probe. Again, probe marker to the patient's left. We're directed sort of up into the patient's left, and we see the liver in the near field. RV sits on top of the liver, on top of the diaphragm, so that's going to be the first chamber we see. LV deep to that, and then you can back figure what the RA and LA are. So a few things that we can assess in this view, the RV free wall. So if you're concerned that the RV is big, you can measure the thickness of that free wall to determine whether that's an acute or chronic finding, right? Is it an acute pulmonary embolism, or is this like pulmonary hypertension that's been there a long time? RV versus LV size. So comparing the two chambers side by side, the RV should be about 2/3 the size of the LV. If it's equal in size to the LV or bigger, that could be indicative of right ventricular enlargement. And we're looking for effusion or tamponade and assessing right ventricular function subjectively. So our RV is sort of pizza shaped and it contracts longitudinally. So like from base to apex, it almost sort of peristalsis. Or it looks like sort of a jellyfish. And then the LV is more bullet shaped, and that contracts in a more concentric fashion, right? So sort of squeezing. So here's our colorized anatomy. Shout out to Pocus Atlas. We've got liver here in the near field. Our teal outline is for the RV. Then blue is the RA. And then deep to that, we've got our LV in purple and our LA in green here. And then they're also sort of marking off the diaphragm, it looks like, with the orange. This is an image depicting a pericardial effusion. This patient also has ascites, so you're not seeing liver in the near field there. Probably it's a cirrhotic patient whose liver is contracted a little bit from cirrhosis. And so we've got ascites here labeled with the A. Our P denotes that pericardial effusion, and then we've got all of our chambers here, RV, LV, LA, RA. That LV looks very thick, so it's probably some kind of hypertrophic cardiomyopathy, and then you can see a pericardial effusion tracking around it. This is an example of a thickened RV free wall. So normal is going to be between 0.1 and 0.5 centimeters, or 1 to 5 millimeters. And here they're measuring, remember, axial resolution is best on ultrasound. So we're trying to measure in that up and down dimension. And this RV free wall is about 1 centimeter thick. So this is probably a chronic process that's led to RV remodeling. Normal 0.1 to 0.6 or 1 to 6 millimeters. Here's an example of an even bigger effusion, and you're seeing some tamponade physiology too. So if you keep an eye on that RV free wall, it's almost like it's doing this thing. So not great. That should be drained. Apical 4-chamber view. This is probably the most challenging to get reliably and well. And the biggest thing with this is just make the patient lay on their left side. So that's going to give you your best image. Don't try to do it with them flat on their back. Sometimes you'll get it, but most of the time you're going to get a much better image if the patient rolls over to their left side. Here you can see the probe marker is directed sort of towards the left shoulder. I think about this as like a peristernal short axis view where you've just kind of tracked off the edge of the heart, and then as you roll over the edge of the heart, you're directing the beam kind of back up towards this shoulder over here, towards the right shoulder. So you're cutting through the apex and you're trying to look back through all 4 chambers. Here's our colorized version. Again, LV more bullet shaped, RV more pizza shaped. We've got our LV outlined here in kind of a royal blue, and then RV in red. and then our RA and LA deep to those things. The best view, you're going to see both valves at the same time, so that mitral and tricuspid valve. You're also going to see the atria. Sometimes if you fan forward, right, so you keep fanning this way, you're going to look at the anterior surface of the heart and you're going to see the aorta also. So that right there, you can see the aorta. That's called an apical 5-chamber. So when you've got both atria, both ventricles, and that LV outflow with the aortic valve, that's a 5-chamber view. So here's an example of a pretty severely reduced EF in an apical 4-chamber view. Notice the difference between this and if we look back here. You're getting good squeeze, right? Those walls are coming together pretty well. You're also seeing migration of those valves towards the apex with each squeeze. So that that's that annular plane systolic excursion. And in this view, right, just very little motion. So we're not seeing those valves travel towards the apices very well. We're also not seeing the walls come together much at all. All right, this heart is moving around quite a bit, but that's because there's a big effusion here. Right, so we've got a nice big effusion kind of tracking all the way around the heart. They've dropped an M mode line, and it looks like what they're trying to gather is if the RV function is reduced. You can measure how close the RV tricuspid annulus, so that housing of that tricuspid valve, how close does it get to the apex with each squeeze? That's called a TAPSE, or tricuspid annular plane systolic excursion. And when that's less than 16 or 17 millimeters, that's indicative of reduced right ventricular function. This again, though, just a big old effusion, probably tamponade. It's moving a little too fast for my eye to pick up. Yeah, so the tamponade physiology here. Here's an example of right ventricular pathology. You might find what we see here is a little bit of reduced function. We're not seeing this valve housing travel quite as far towards the apex. And then if you keep your eye right here, it sort of looks like somebody's jumping on this right ventricular apex, like they're jumping on a trampoline. That's called McConnell's sign, not named for Mitch McConnell probably, but it can be indicative of a PE if it's the right clinical context. It's not specific for that, but it's a finding that you might find. Here's another example of McConnell's sign. You got this RV apex sort of bowing in. And then what you also see right here in the middle is very bad news. That's a free thrombus inside of that RV. So that should make everybody's sphincters pucker. That's pretty specific for a PE. You see McConnell's sign and a clot inside the RV. It's like, that's, PE till proven otherwise. The other thing we can keep an eye on here is that RV tricuspid annulus, again, not migrating towards the apex very well. So if you want to measure that, you drop an M mode line along that housing and along that lateral border of the valve, and then you can measure peak to valley. So less than 16 millimeters is abnormal. And that's it. Get to scanning. You guys can practice obtaining your sub-xiphoid views, trying to freeze and measure that RV free wall, and then additionally trying to get your apical 4-chamber views, maybe even try some apical 5s. And if you'd like, you can try also measuring some tricuspid annular plane systolic excursions.